Good morning, everybody. This is a live update on the severe weather setup that looks to be impacting northwestern Oklahoma, maybe across the northern Texas panhandle as well, and extending east across north central Oklahoma as we go through the evening hours, maybe even an hour or two after sunset. Definitely a couple hours after sunset. It looks like supercells could persist with that conditional tornado threat. And there is even a pseudo cold core setup too, back across the northern Texas panhandle. Even though that 850 low isn't quite closed off, I do think that there is a chance of some low top supercells developing off across the northern Texas panhandle, across that occluded boundary back there. But first I wanted to show you this target area. This is the general target area, pretty straightforward across northwestern Oklahoma. I do think that supercells are going to develop across the northeastern Texas panhandle by about 4 or 5 p.m. And then push in to northwestern Oklahoma and eventually across north central Oklahoma as well. But this is the main axis here of the low-level jet, and it initially pushes east of where the storms are going to form by late afternoon. But then as we get a little bit closer to sunset, and especially after sunset, by about 5, 6, 7 p.m., that's when this low-level jet begins to build back closer to the storms. And if supercells can still maintain discrete modes, then I do think that there is a tornado threat that's really going to ramp up as we get closer to 0Z. Here is this 850 trough axis back to the west. This is where those supercell storms are going to develop. Textbook elevated mixed layer, or a dry slot, is also coming in at the mid-levels of the atmosphere. And here is the lift. This is basically 500 millibar height contours. The lift there is shaded in the darker red areas. And here you can see the lift associated with this vortmax. That's because of vorticity advection as well. This is the maximum in vorticity. So anything to the east of it or downstream, you're going to have positive vorticity advection, or vorticity that's increasing with time ahead of the system. And that creates lift. And you can certainly see this lift moving into the northeastern Texas panhandle by about 21Z. That's about 3 p.m. And as this lift overspreads the instability axis here in northwestern Oklahoma, the nose of that instability axis, that's when initiation of supercells is going to commence. That's going to be at around 4 or 5 p.m. And you can see a lot of this lift is also coming into western Kansas there. But the thermodynamics are really going to prevent severe weather from happening much further north of the Oklahoma-Kansas border. The nose of that instability axis is punching right into northwestern Oklahoma there. You've got a clear slot that's coming in around the south side of this vort. That clear slot is arriving just a little bit late. If this system were timed a bit earlier with greater moisture return, then we'd probably be talking about an outbreak of severe weather, including tornadoes. But the late arrival of this elevated mixed layer, a little bit of some subtle ridging downstream, but not a very sharp ridge happening downstream. And that's encouraging kind of modest moisture return with dew points in the mid to upper 50s, maybe a 60 dew point up toward the I-40 corridor. We're going to break down the surface map, monitor that moisture return. We're also going to monitor the soundings, the hodographs, the individual variables from the different models, the HRRR, the RAP. But first we're looking at the general view of the whole, the larger scale. And this is a neutrally tilted trough right now. So it's still intensifying, reaching peak intensity just as it's ejecting from the Rocky Mountains across the southern plains, going from a positive tilt to a neutral tilt, and eventually to a negative and a closed off upper low across Illinois, where there could be a cold core setup, probably an arc of supercells moving through central and southern Illinois on Wednesday. I think that the southern portion of that mode is going to be less favorable for tornadoes, with that wind shear ejecting to the east and to the north of the instability axis. But the northern part of the instability axis tomorrow across central and southern Illinois certainly could have a tornado threat. But this is that lift, that vertical motion that's associated with vorticity advection downstream of that trough. And once that vertical motion slides over the northern Texas panhandle, that's going to initiate some low top convection along a west to east oriented boundary that becomes a cold front. And then it's eventually going to initiate supercells across northwestern Oklahoma, probably just to the west of the Woodward area. And those are going to slide to the east across north central Oklahoma, eventually catching up with that low level jet by about 6 p.m. And that's probably really when the tornado threat is going to ramp up, right at about sunset. That's when the low-level jet is going to extend west to those ongoing supercell storms. And here is that clear slot, showing you this on the Wonderful pivotal weather imagery here. You can see that dry slot of air punching in to the Texas Panhandle there. That is the elevated mix layer, as we call it. Let's see if I can find this map so I can annotate it. So this right here is that clear slot punching into the Texas Panhandle by about 18Z, and then eventually by 21Z it starts to overspread the nose of the instability axis there in northwestern Oklahoma, very close to the Woodward area. And these elevated mix layers are key to generating the severe weather that generating instability that leads to severe weather. You get this dry air that comes in over top, the heat and the moisture that leads to cooling at the mid-levels and a steepening of those lapse rates while you retain the heat and the moisture at the low levels, and that causes instability to build. And when these elevated mix layers arrive just a little bit earlier, closer to peak heating, then we'd get a lot more heating across western Oklahoma. But still, this is a stout elevated mix layer coming around the south side of that vortmax, and this is going to contribute to about 1,000 to 1,500 CAPE across western Oklahoma, and the nose of that instability axis up in northwestern Oklahoma, just ahead of this greatest lift as well. Vorticity of action is maximized there, ahead of this elevated mix layer. Basically a ski jump configuration to the upper jet. You want to target the nose of that jet max as well as it comes around the south side of this vorticity maximum. And everything is pointing toward northwestern Oklahoma, a very routine, easy target for severe weather. But there are some negative factors definitely that could prevent tornadoes from happening. Many of the soundings are showing a bit of a stable layer that develops at the surface because of those marginal dew points. And as we get closer to sunset, that nocturnal inversion is therefore going to be more pronounced. And that could cause many of these supercell storms to go a little bit elevated as they progress east out of northwestern Oklahoma and finally arrive to that the western side of that low-level jet axis, which is going to propagate back west to these storms as we get closer to sunset. That's usually when the low-level jet ramps up. When you get closer to evening, you get a little bit of cooling at the surface. That causes a decoupling of the wind profile, a ramping up of the southerly winds just above the ground, about 1 kilometer above the ground, and that is crucial for tornado potential. And that's why you often get a maximum in that tornado potential evening and also extending just a couple hours after sunset. Here you can see the ski jump configuration in the upper jet. Basically the nose of that mid-level jet, that's where the ingredients really come together for tornado potential. And that's why the Storm Prediction Center has a slight risk that extends all the way back to the northeastern Texas Panhandle now. This is a potent upper-level storm system, and I did mention that there could be the threat of a pseudo-cold core across the northern Texas Panhandle as that elevated mix layer overspreads. It goes over top the northern Texas Panhandle. That'll be low-top convection. And I say pseudo-cold core because a cold core event really requires a closed upper-level low, and this is definitely an open wave right here that's moving into the southern plains. That's sending a low-level jet just a little bit further east of where the storms are going to happen. But there is going to be a west to east oriented boundary that's going to eventually become a surging cold front that's likely going to help to force some elevated storms here as well across northwestern Oklahoma. But supercell storms ahead of that front do appear possible, as many of the convective allowing models are showing that. The HRRR, the RAP model also is showing convective initiation across northwestern Oklahoma. The NAM model shows a complex of storms moving from northwestern Oklahoma across north central Oklahoma late. But this is there could be some pseudo cold core convection across the northern Texas Panhandle. But this system closes off a bit more across Illinois tomorrow. So more of a traditional cold core setup or an arc of supercells is likely going to evolve across central and southern Illinois during the afternoon hours tomorrow. But here is that open wave punching into Oklahoma, targeting the nose of that ski jump there. Here's the RAP model, the RAP forecast for about 19Z. So this is by about 1 p.m. And you can already see convection developing along that cold front across north central, across the northern Texas Panhandle. And depending on how rapidly that cold front surges off to the south, I wouldn't be surprised to see some land spout reports here out ahead of that front before it begins to surge. It's really going to start surging through the early afternoon hours, but you can see this instability axis really building across western Oklahoma as that elevated mix layer is punching into this and actually moving over top the moisture at the surface. So you're going to have dew points in the mid to upper 50s, maybe a 60 punching up to the I-40 corridor. You're going to have some convection already developing along this cold front before it really starts to surge off to the south. But really the nose of this instability axis across northwestern Oklahoma, near and to the west of Woodward. Initiation likely around 4 to 5 p.m. And they're going to be large hail-producing supercells initially. The low-level jet appears to push off to the east across central and eastern Oklahoma, which will initially reduce the low-level shear available to these early supercells that form across northwestern Oklahoma. So they're probably initially going to be hailers, big wall clouds, big updraft bases. And if they can reach the low-level jet here by 6 p.m. or so, 5 to 6 p.m., that's when they could develop a tornado threat. There is a chance, though, that this front could surge and undercut those storms, preventing that tornado potential across northern Oklahoma. There is late arrival of moisture. Many wise storm chasers and meteorologists have told me, never trust new moisture, but in western Oklahoma, that's one place that you could probably trust that new moisture. And here's the 850 jet. This is the low-level jet showing that it pushes off a little bit to the east. This is at 21Z. This is the NAM forecast low-level jet. And this is to the east of that open wave in response to those pressure falls to the west over the higher terrain. And you can definitely see that low-level jet pushing across central and eastern Oklahoma. But the storms are going to fire right here, right underneath this developing 850 low. And the shape of this 850 low is southwest to northeast, and that causes this low-level jet to initially be displaced off to the east of where the storms are going to develop. So these storms are going to develop across northwestern Oklahoma there into the northeastern Texas Panhandle, right underneath the core of that 850 low. But you can definitely see the 50 knot and greater low-level jet is in central and eastern Oklahoma into southeastern Kansas, with a bit of a weakness in the 1 kilometer flow where those storms are going to develop. But if they can maintain supercellular modes and then eventually move into northwestern and north central Oklahoma by about 6 p.m., that's when the western gradient of that low-level jet is going to meet the storm. So it's going to build off to the west. These supercell storms are going to be marching off to the east and to the northeast, basically a complex of storms moving from northwestern Oklahoma across north central Oklahoma. And if they can reach the western gradient of that low-level jet, then all hell could break loose. We could have tornadoes starting at about 6 p.m. across northwestern and north central Oklahoma. I definitely was planning on chasing this event. I didn't get on my flight this morning. I'm here visiting my mom for Thanksgiving. Just got out here, and she encouraged me to stay here and do live weather briefings, live radar breakdowns. But I'm definitely going to be watching this event closely, doing non-stop weather briefings throughout the day, watching these evolve on radar from northwestern Oklahoma, eventually moving in to north central Oklahoma. So now let's zoom in a little bit to that 850 jet. This is the zoom in. This is the HRRR model, and this is at 21Z. Here you can see this 850 low forming back across northwestern Oklahoma. And I expect convective initiation to happen right underneath this 850 low, right underneath the cold pocket of air at the mid-levels of the atmosphere and at the nose of that elevated mix layer as it ejects from the Texas Panhandle across northwestern Oklahoma. But you can see even on the HRRR model that the core of this low-level jet is across eastern Oklahoma and southeastern Kansas, just a little bit east of where the storms initially develop. This is where they're going to develop at 21Z. And you can see the low-level jet is basically about 15 knots out of the southwest, just ahead of those storms. So for the first hour or two that they evolve, they may not develop a tornado threat as they have a slightly marginal low-level flow. But if they can move into this north-central Oklahoma area, by about 6 p.m., that low-level jet builds back to these storms. The 850 low actually becomes more bulbous, and we could have 2 to 3 supercell storms moving out of northwestern Oklahoma, intersecting the western edge, western gradient of that low-level jet. And really once they reach about a 30, 35 knot low-level jet, that's probably when the tornado switch is going to be switched from off to on. And these supercell storms will start producing tornadoes. They're likely going to produce very large hail throughout their life cycle, though across northwestern into north central Oklahoma. And still though, the timing of all this has to work out perfectly to realize a robust tornado threat. These storms have to maintain supercellular modes from northwestern Oklahoma until they reach the western gradient of that low-level jet, basically until the 500 meter to 1 kilometer winds accelerate above about 30 to 35 knots out of the southwest, and then that's when those hodographs are really going to become favorable for tornado potential. And here is a forecast HRRR sounding just ahead of where these storms are going to evolve. And here you can see that stout elevated mix layer that I was telling you about. This is the dry pocket of air that comes into the mid-levels of the atmosphere, and that steepens these lapse rates. This red line here, that's the environmental temperature profile, cooling with height, and the rate at which this cools with height is called the lapse rate. And a steeper lapse rate is when you have cooler temperatures aloft, basically exacerbated by this dry slot coming in here. That leads to greater cooling with height, greater lapse rates, and a more unstable profile. And in this sounding, this white dashed line, that's the parcel ascent, the theoretical parcel ascent. Basically, if you lift a theoretical hot air balloon, retaining those low-level conditions and lifting through the atmosphere, you can see it's going to be warmer than this red line, and it's going to continue to rise until the temperature becomes equal to the surrounding environment, the environmental temperature, and that's when that balloon is going to start to sink. And this is basically the top of where those storms are going to be, relatively low topped as you might be used to during May and June, but still more than sufficient to develop tornadic supercells, of course. And a very stout elevated mix layer right here. This is definitely a defining characteristic of these big southern plains severe weather events that come together at the last second, right at the nose of the instability axis. Dry slot coming in over top that moisture and that instability, creating a very unstable configuration. Here is the low-level wind profile. Low-level winds southeasterly, shifting to a southerly southwesterly low-level jet. And eventually this low-level jet is going to increase above 50 knots as we get about 6 or 7 p.m. And if we still have supercellular modes that are surface-based by that time, then the tornado threat could skyrocket. But a lot has to come together for that to happen. Here at 500 millibars, you got a nice southwesterly low-level jet, about 50 knots. And this area right here shows one of the weaknesses of this setup for tornado potential. You can see this capping inversion that is still in place. This is at about 23Z, northwestern, north central Oklahoma, ahead of the storms. You can see a very moist, low-level profile. But still, you've got a low-level temperature, about 61 degrees over 59 or so. Not nearly at convective temperature. You'd really need a surface temperature well into the 60s, probably near 70, to be able to break that cap just by surface heating alone. But there is a ton of lift coming in with this storm. And one thing about supercell storms is if they're based close enough to the surface and they develop a strong low-level mesocyclone, then they can drill through this convectively stable layer. And that's called dynamic piping. That's why you get tornadoes that happen well after sunset, despite the development of those nocturnal inversions. That's why the Greensburg, Kansas EF5 tornado happened well after sunset, as those surface temperatures were cooling in an environment greater than 100 joules per kilogram SIN. And that's because the kinematics matter so much more, and the presence of a strong low-level mesocyclone that's close enough to the ground can actually drill through this relatively shallow stable layer at the surface. This one, though, looks a little bit thick for that. So if you compare the forecast soundings that we had for the severe weather event that I chased in the Ozark Mountains about a week ago, that one had a nocturnal inversion that was based very close to the ground. That could have been aided by the terrain a little bit, the elevated terrain of the Ozark Plateau a bit there. But in this case, this stable layer is a little bit deeper across north central Oklahoma, and that could cause these supercell storms to go elevated just as they're reaching that most favorable shear for tornadoes. That's probably the most likely scenario that's happening, but it's Oklahoma. Crazy things happen out there. Usually this new moisture that arrives like this, the noses of these modest instability axes with very dynamic upper level storm systems with a lot of lift, they usually happen in Oklahoma. And here is the hodograph, very favorable hodograph for tornadoes. You got a northeasterly storm motion at about 30 knots. You've got a 1 kilometer wind, south-southwest at about 40 knots. You've got a backed, relatively weak surface wind at a southeasterly direction. Nice Ekman spiral there, basically the changing wind speed and direction with height, creating this hook here at the low levels. And the larger this hook shape in the hodograph, the more favorable is the low-level shear. And this one is before 0Z because you can see that the low-level jet has not accelerated above 50 knots yet. And so the Hodograph actually gets more favorable as you go through the evening and get further after sunset. As that low-level jet ramps up, it's going to have more of a shape like that. But there is a bit of some veer-back veer, and I'm not a big fan of the negative helicity contribution from these veer-back veer profiles. But when you get this S shape at the higher levels of the atmosphere, this is actually a negative contribution to the storm relative helicity. You can call that negative helicity. Will the positive contribution of the low levels of the atmosphere, which are really more relevant, will that outweigh this negative contribution to the helicity in the Hodograph? I think they usually do, especially with strong enough wind fields and a low-level jet that's ramping up. But in this case, the low-level jet is initially going to be well east of these storms for the first couple hours of their evolution, and they're going to have to hold on to their supercellular modes until they reach the western gradient of that low-level jet to develop a really robust tornado threat. But still, this Hodograph here is about marginally favorable for a legitimate tornado threat. The negatives with this are that stable layer, the deeper stable layer at the very low levels of the atmosphere. The low-level jet starting off to the east because of that southwest to northeast shape, stretched out appearance to the 850 low. Really getting that bulbous look to it later on this evening as we get closer to 0Z. But there is going to be increasing helicity as we go through the evenings, extending after sunset, available to these storms. So now I'm going to break down the HRRR model and really show you the evolution of this low-level jet. Here you can see the shape of that 850 trough, really stretched out from southwest to northeast initially. This is at 18Z. The elevated mix layer is overspreading the Texas Panhandle at this time, causing mixing and a weakening of that low-level jet. And this southwest to northeast shape of that 850 trough is going to cause the low-level jet to shift into eastern Oklahoma and southeastern Kansas there, well east of where the storms are going to initiate. Some of the previous models were also showing a mode of discrete supercells developing down near the Arklatex region. That's going to be on the east side of that instability axis. And that mode is a bit more conditional. The HRRR run-to-run has been wavering back and forth on whether that mode forms. And really with a majority of the 500 millibar lift and vorticity advection coming into the southern plains late by about 22Z, I think confidence is quite low in the evolution of those supercell storms down near the Arklatex, at least earlier in the evening. I could see like a 9, 10, 11 p.m. type of an initiation out there of that mode. But you really don't have the very deep moisture that is just infiltrating Dixie Alley like you'd have with a much bigger storm system. Seems like we have kind of a skinny instability axis. The moisture is just a bit modified. But let's step through here hour by hour, see the core of the low-level jet. So watch this western gradient of the stronger winds. This is the 850 millibar forecast from the HRRR on the Pivotal Weather website. I expect supercells to initiate back here along this 850 trough and ahead of or near the cold front dry line intersection that we'll analyze in a second. And this is at 19Z, still about 3 hours before the storms initiate. And really by about 22Z, this is 22Z, this is when the storms develop, when that 850 trough shifts east, the cold front begins to surge. This is about 3 hours after that pseudo cold core event that was in the northern Texas Panhandle. You can see the southern edge of this 850 trough is getting a little bit more bulbous, so things are coming together late. And this is at 22Z here. You can definitely see at 22Z, stepping one more hour up to 23Z. And watch the western gradient of this low-level jet. Still here, it's pushed east. It's east of I-35, the core of that low-level jet at 23Z. This is at 5 p.m. when this happens. You're going to have supercell storms ongoing in the Woodward area. And the question is, can they move east of this 850 trough axis? Or can this 850 low get a bit more bulbous and allow these storms to move off it, move into that stronger low-level winds, the stronger low-level jet? That's really the key to getting tornadoes with this setup. Let me show you these supercells ongoing by 23Z up here. These are the supercells in northwestern Oklahoma. Likely 2 to 3 supercells will be lined up to the south of this front. These ones up closer to the Kansas border will probably be starting to get undercut by the surging cold front What's left over of that pseudo cold core convection back in the northern Texas panhandle is just post-frontal stratiform rain by this time. So this is at 6 p.m. This is going to be the peak of the tornado potential if these storms can maintain their supercellular characteristics for another hour or two after this time. That's when the tornado threat is really going to ramp up across north central, northwestern Oklahoma between about Woodward and the Enid area. This convection down here is likely at the nose of a surging cold front there, but let's see how the low-level jet evolves. That's really why we're doing this exercise, is to watch the western gradient of that low-level jet meet the storms. So this is at 0Z, and you can start to see these low-level winds back a bit. They're now south-southwest just ahead of the storms. This is at 6 p.m. Central Standard Time. And really any of these supercells that still have a supercellular mode, if they're able to maintain it from the northeastern Texas panhandle all the way into this area, this is when they're going to start producing tornadoes. The low-level jet increases about 40 knots here by this time. This is where I picked that forecast sounding as well to really show you that looping hodograph. See how this is getting a lot bigger. Still, though, we've got that capping inversion at the low levels and a pretty deep stable layer that happens. You can really see it here in this plot of Theta-E. Stable layer. Stable layers at the low levels from that cap all the way down to the surface. So the question is, will these supercells be surface-based by this time to tap in to this incredible wind shear that's located just to their east? Here you can see the low-level jet south-southwest increasing to close to 50 knots ahead of these storms. And now you can see that the positive contribution to that storm relative helicity is outweighing the negative contribution from this veer-back veer profile, basically this S-shaped hodograph profile that you can see there. Hopefully you can see my mouse as I'm live streaming this. But you got to watch the western gradient of this low-level jet through the day today, going to 1Z and through this evening. Look at it ramp up ahead of these storms. 55 knots there, 50 to 55 knot low-level jet ahead of these storms. Let's look at the forecast hodograph there. And now you're going to see a giant hook-shaped hodograph. This positive contribution to the storm relative helicity vastly outweighs this little kink from veer-back veer. So really, if these can maintain supercellular characteristics through about 6 to 7 p.m. standard time, look at this 850 low. Get this closed look to it, closed off look. This is a more of a compact bulbous 850 low, pulling that low-level jet back to these storms. So instead of kind of a southwest to northeast sheared out 850 trough axis, now you've got a well-defined 850 low as this upper level system is intensifying while ejecting from the southern Rockies across the southern plains. So really the timing is really the only negative factor. And if this was during May, we'd probably be talking about an outbreak of tornadoes across northern Oklahoma down into western Oklahoma. But by this time, you start to get a veering of the low-level flow on the south side of that trough, with that trough axis, the main trough axis, continuing to march east across the Ozark Mountains. And you can see the HRRR is starting to undercut these supercell storms just as that low-level shear is really ramping up. So if these are supercell storms and they're based at the surface, which the forecast soundings are showing them probably to be elevated, but with such a strong low-level jet just to their east, there's a chance that they could drill down and maintain the tornado threat through even 7 p.m. standard time to the north of Oklahoma City. So the latest HRRR runs are not showing any convective initiation along the I-40 corridor. You can see this model late, well after sunset, you start to get the development of this mode down near the Arklatex up through the Ozarks and beneath the core of that low-level jet. The concern for that mode is that the instability may not be quite there. It's right on the eastern edge of that moisture axis. You've got dew points in the low 60s there. Usually for these nocturnal Dixie Alley Ozarks events to really crank, you need dew points in the mid 60s there. A little more of a robust moisture axis that fills in well to the east of this system. And then you kind of get the 1-2 punch. You chase the Southern Plains event, then you chase the Dixie Alley event. But if the timing of this system, if this were ejecting a bit earlier, pulling this moisture up earlier with that elevated mixed layer overspreading western Oklahoma near and just after peak heating, then I think there's going to be a decent chance of an outbreak of supercells. But here you can see that cold front surging south to the Oklahoma City metro, instability axis to the east of it, Triple point just to the north of the Oklahoma City metro. Nose of the instability axis into northern Oklahoma. Kansas largely north of the instability axis. So even though a lot of the lift is heading up towards southern Kansas, you're just not going to have any surface-based instability up there. Looking at the surface-based Cape axis. And really that low-level stable layer from that capping inversion down to the surface, that negative contribution to the buoyancy is definitely showing kind of a meager instability axis, but this is at 1 p.m. And the nose of that instability axis from northwestern Oklahoma following it all the way across north central Oklahoma is really where you want to target today. Probably start off in the Woodward area where you've got a lot more Cape even approaching 2,000 out there. Here is this front starting to surge. Triple point probably near, just to the west of Woodward, probably down near the gauge area. And that's where you'd likely want to set up near Woodward and just wait for those storms to initiate. And here you can see what beautiful surface-based instability looks like. No low-level stable layer available to these storms initially. But while that's happening, you can see the low-level jet here is only at about 20 knots. So the low-level wind shear really ramps up as we get closer to sunset, about 6 to 7 p.m. But plenty of surface-based instability available to these storms, even with a 63 to 59 profile. Near that triple point, you can see a pretty small hodograph here initially. So this is what these initially surface-based storms are going to be sampling in terms of low-level shear. A 20-knot low-level jet out of the southwest. But if they can hang on to those supercellular modes until the low-level jet increases above 40 knots by about 6 to 7 p.m., then we're going to be talking about a big tornado potential. But with all this 5-6 kilometer winds up here above 60 knots, plenty of bulk shear for initial supercell storms, probably large hail producers there to the west of Woodward happening. Oh, I thought that was Gizmo. Here's that 6 kilometer bulk shear. Just starting to ramp up across western Oklahoma, but well in excess of 50 knots. More than supportive for a supercell storm. So this is a intensifying trough as it's coming out of the southern Rockies into the southern plains. The timing is just a little bit late relative to the diurnal cycle this time of year. But I do think that there is a decent chance of tornadoes. We have the supercell composite just for fun. Much of the supercell composite is I-40 southward because that's where most of the instability is located. You really want a supercell composite that is places a greater weight on the low-level shear for tornadoes. But right at the nose of this supercell composite is when that tornado threat really ramps up. This is at 23Z. This is at 5 p.m. Very close to Woodward. You've got a supercell composite approaching double digits out there. A hodograph that's rapidly expanding. You start to lose that surface-based instability a little bit right as the wind shear ramps up. But with these low-level cyclones strengthening like this, they should be able to drill through a stable layer that's this shallow. So there definitely is a window for tornadoes. 5, 6, 7 p.m. for these storms as they move into that low-level jet. Once it accelerates above about 30 knots, that's when we start to get wind shear favorable for tornadoes. Still a skinny axis, but these happen in western Oklahoma. These end up producing out there. Watch the supercell composite become a bit more robust, but definitely peaks between 23Z and 1Z from northwestern Oklahoma across north central Oklahoma, eventually arriving at the I-35 corridor by about 7 to 8 p.m. And many of these, the HRRRs, showing these supercellular storms maintaining supercell characteristics even all the way to the I-35 corridor by about 7 to 8 p.m. So this event's going to be gauge area, Cheyenne to gauge through Woodward up to the I-35 corridor. Most of the models are showing convective initiation to be north of the Oklahoma City metro. Late night tonight, we do need to watch the development of those renegade storms over the Ozarks, Arklatex to the Ozark Mountains. There you can see that convective line starting to form. By this time, by 3Z, by 9 p.m., you're going to have now an arc of elevated storms lifting up into Kansas ahead of that main lift. The rest of Oklahoma remains dry by this time. And then we've got that convective line that forms from the Arklatex through the Ozark Mountains into central Missouri, and a possible formation of a cold core event on Wednesday way out here in central and southern Illinois. And we're definitely going to have to keep an eye on that. We'll be doing more weather briefings tomorrow for that event. Maybe a possibility that Dixie Alley could be active. But for the most part, the wind shear ejects to the northeast of this slower moving instability axis. But definitely want to keep an eye on central and southern Illinois for the development of an arc of low top supercells, maybe back toward western Kentucky into western and central Tennessee. But really the wind shear lifts to the northeast of this region. But those hodographs are still quite favorable in the morning hours across western Kentucky, western Tennessee, and better wind shear across central and southern Illinois up there. NAM, everybody in agreement here with that instability axis right along the central Mississippi River Valley by 18Z, or about midday, with the nose of that instability starting to bleed in to southern Illinois. So this convective line is going to be ongoing tomorrow morning through about midday, so I wouldn't be surprised to maybe see some tornado warnings, but quite an anemic convective line by this time tomorrow morning. But still, got to watch southern Illinois ahead of this front for the development of an arc of low-top supercells through the early afternoon hours. But really, a lack of convection moving through by tomorrow morning. Maybe some convection early down into western Mississippi. That could be interesting. They'll have to keep an eye out tomorrow. But boy, it looks like most of the severe weather is going to be today across Oklahoma, the southern plains. 18Z, you start to get the development of some pseudo cold core, low top convection out there across the northern Texas panhandle before that front surges. Might even be able to squeeze out a land spout or two there, but that front starts surging pretty quickly. And by 22Z, you get the development of supercell storms across northwestern Oklahoma. Initially, that wind shear is going to be a little bit marginal, but they're going to be moving in to that strengthening low-level jet as we get a little closer to sunset. This is about 4 p.m. Central Standard Time, and you're going to have mature supercell storms lifting from the gauge area up through Woodward, and then they start to get undercut. Well, they never really get undercut. They might get a bit elevated by that stable layer, but cyclogenesis is rapid enough here that it could keep these storms kind of out in the open warm sector. But you can see here by 0Z that front really does start to surge. So that's another failure scenario for the tornado potential, is this surging cold front. Supercells may go up initially. Low-level shear may not quite be sufficient for tornadoes, and then the cold front will come in and undercut them. But if cyclogenesis ramps up fast enough, which it doesn't look like it's going to do on the latest runs of the HRRR, then there's a decent chance that these storms could stay ahead of this front, anchor on that triple point, and really finally move into the western gradient of that low-level jet as they get closer to the Enid Woodward area by about 6 p.m. So that's really what we're looking at today. Let me see if we got some... Yeah, so even though I am sitting out this particular chase for this one, I'm definitely going to be in full-blown chase mode when more Dixie Alley events begin to erupt. I'm based at my mom's house here in upstate South Carolina. Very easy place to catch severe weather in Dixie Alley. Still keeping a close eye on tomorrow too, but I think tomorrow's going to be relatively weaker convection. Here is the latest WRAP forecast. And you can see the effective helicity on the very eastern side of that instability axis, right near I-35 corridor by 20Z. So this is about 2 p.m. We've got some convection that develops along that front in the northern Texas panhandle. Maybe a land spout or two up there. Eventually that front starts to surge, undercuts all that convection by about 1 p.m. pretty quickly, but there's a narrow window for a land spout across the northern Texas panhandle, midday, maybe into the early afternoon hours before they get undercut. And then that low-level jet shifts to the east, closer to the I-35 corridor. Then supercells will develop by about 3:30 to 4 p.m. They'll have a large hail threat, probably some big bases, big wall clouds. But it'll take them a while to reach that low-level jet, and there's a chance that they're going to get undercut by the surging cold front before they do so. But that narrow window between about 5 p.m. and 8 p.m., there definitely is a chance for supercell storms to happen. And we're just not, we could look at the RAP model here on the Pivotal Weather website. So here's the RAP model forecast. And the RAP model also has supercells developing all the way down to the I-40 corridor. And if that happens, then you're going to be bringing that severe weather, hail potential, even that tornado potential all the way down to the Elk City, Clinton areas down here. So that's the RAP at about 22Z. So also at about 4 p.m., it has a nice cluster of supercells from western Oklahoma, northwestern Oklahoma, lifting northeast to the Woodward area by about 23Z. This is probably about 5 p.m. So really all the models are in agreement for the development of that cluster of supercell storms developing down near Gage to Cheyenne, up toward Laverne, lifting east and northeast across the Woodward area, Alva, eventually up toward Enid, and eventually approaching the I-35 corridor in north central Oklahoma by about 6 p.m. Let's look at what the environment is showing here on the RAP. See if that low-level jet is maybe banked up against that convection. And it's really not. So there's definitely a weakness. You can see how this 850 low is initially stretched out from the southwest to the northeast direction. That causes this low-level jet to get pushed off into eastern Oklahoma and southeastern Kansas, even all the way to the Ozarks. Eventually it gets that more bulbous appearance as you get closer to 23Z and about 0Z. That's when the tornado threat would be maximized of this, and that low-level shear will be available to those storms. But it looks like thermodynamically and with a surging cold front that there's a chance that they may not be surface-based supercells when they do reach the western edge of that low-level jet, which the RAP is showing pushes even further east into eastern Oklahoma and the Ozarks. And by 23Z still has weakness in the low-level flow in the vicinity of those storms. And then you can see the RAP by about 0Z, 6 p.m. starts to get that more bulbous appearance to the 850 trough, 850 low. Look at it really start to close off down there in the southern plains. And if this process were to happen earlier, about 3 hours earlier, then we'd be probably talking about a little mini outbreak of tornadoes across northern Oklahoma, and that still could happen. This isn't the answer key for sure. And then you can see these low-level winds about a kilometer up finally start to veer across central Oklahoma there. And we're going to be breaking down all this stuff down to its fundamental level, down to its elemental levels here coming up when I launch the Storm Chasing School. That's going to be happening before the end of this month, maybe early December. And then every week we're going to be going over basic meteorology, storm chasing strategy, really how to make ends meet and make a living storm chasing as well. I'm going to be breaking all of that down, live streaming it to all these social media platforms. But really, the Facebook supporters will get exclusive access to this, the Storm Chasing School coming up here. And even though I'm not chasing today, that doesn't mean that I'm not in full-blown chase mode through the end of the year. I'm definitely going to be watching Dixie Alley during this late season for more setups. This one, though, I just got to my mom's place last night here to finally see her for the first time this year. And I just couldn't fly out this morning all the way to Oklahoma City to chase this one day and then come back and potentially expose them to the flu or something else. So I'm staying put, and I'm going to do radar breakdowns, breaking down the environments ahead of these storms, breaking it down in real time for you here live. We'll use the Radar Omega app to look at these storms as they play out in real time. And there was one thing that I forgot to look at, and that's the surface map. This is a surface map from a little earlier this morning, but shows the moisture advection well underway. And a lot of people say never trust new moisture. Well, in Oklahoma, you can. You can trust the new moisture when it arrives. And a lot of times the late arrival of sufficient moisture for severe weather gets here just in time. The nose of the moisture axis will light up. You can see we had a little bit of a complex of some stratiform rain there moving through Oklahoma, maybe even increasing the low-level moisture a little bit. And we're probably going to have a mixing down of moisture happening too as this low-level jet continues to transport the moisture all night last night through the morning hours, more rapidly just above the ground than right at the surface. So you're probably going to see many of these dew points start to increase as the heating of the day commences and we go toward the late morning hours, closer to midday. That greater moisture that's streaming in just above the surface will be mixed down, and you might even see a jump in those dew points from the low 50s up to the upper 50s just before storms fire. But really, you've got upper 50s dew points starting to approach the Red River down here, 60s dew points further south. These are a little bit modified. You'd like to see those mid to upper 60s dew points right along the Gulf Coast for these severe weather setups. But we've got a reamed out Gulf of Mexico after this record-breaking hurricane season. They had the Ozark severe weather about a week ago as well, where we had greater moisture. But still, it can happen with low to mid 60s temperatures, dew points in the upper 50s. Could definitely get supercells and even tornadoes across northwestern Oklahoma. So that's my live briefing this morning. Thank you everybody for joining me. This is officially the target area across northwestern Oklahoma. We discussed the reasons why. We discussed the limiting factors for tornadoes that could emerge and why this is a conditional tornado threat. We broke down hodographs. We looked at the evolution of the low-level jet relative to the position of these storms. And I think that we now have a pretty big-time handle of this storm. If I were chasing this, I would just head up to Woodward, probably a little west of there, maybe near the Gage, Laverne area even, and just watch these storms evolve, watch their wall clouds, and maybe see a tornado just before sunset. Probably drive in and out of the hail core, maybe blow the windows out a few times. But that's what storm chasing is all about. Also deploying instrumentation. I would likely deploy the subsonic sensors, maybe a network of these gravity wave sensors around these supercell storms to really see what kind of gravity wave and infrasound signals that they have. But the main deal is that elevated mix layer, that dry slot of air that comes in off the higher terrain. And one thing about these eastern U.S. outbreaks is when you bring aspects of Great Plains severe weather outbreaks and bring them east into the eastern U.S., that's when you get outbreaks. So when you bring that dry slot of air in the mid-levels of the atmosphere to the eastern U.S. and you have a very progressive upper-level storm system, that's exactly what happened during the super outbreak of 2011, and that's when you get those big Dixie Alley outbreaks. And that type of a scenario happens more often with La Nina spring. So when you get cold water in the tropical Pacific and during the winter into the spring months, that's what happened in 2011. That's why you had a consolidated polar front jet, big open wave surging through Dixie Alley, and that's what created those big Dixie Alley outbreaks of April 15 and the super outbreak April 25 through 27, 2011. I'm not saying that's going to happen this spring, but I am saying that the climate system favors a consolidated jet with maybe some potentially more prolific outbreaks across Dixie Alley. And I did forget to show you what the SPC has out today. They've got a slight risk across, basically extended a little bit further west into the far northeastern Texas Panhandle, across northern Oklahoma. They extend the marginal risk across the Arklatex and the Ozarks region just for the outside chance that that nocturnal mode of some renegade storms and that convective line develops there tonight. I think that is going to happen probably around 8, 9, 10, 11 p.m. out there from the Texas Piney Woods through the Arklatex into the Ozarks. And the Storm Prediction Center has a small 5% area for tornadoes across northwestern Oklahoma, centered over the exact area that we identified. They also have a 2% risk across the northeast Texas, the Arklatex into the Ozarks, for the potential development of that convective line late night tonight, and a potential for significant hail even windshield shattering hail out there with that intense elevated mix layer coming in. Those steep lapse rates available to these storms, a lot of instability. Supercell storms are basically a certainty out here at the nose of that instability axis. Tornadoes, less of a certainty, more of a conditional threat, but really well done outlook by the Storm Prediction Center. Here's the Reed model showing the target area across northwestern into north central Oklahoma there. And I put 5 to 10 p.m. there, but really about 3 to 4 p.m. is when those supercells are going to develop across maybe Canadian Texas out through Gage, Laverne, further east, eventually moving toward Woodward. And the RAP model has those supercells down near the I-40 corridor, so keep that scenario possible. Elk City, Clinton. Jimmy Taylor, if you're watching this, definitely be in chase mode down there in Elk City along the I-40 corridor, waiting for these storms. But this is the target area, and this is what we're going to be watching. We'll watch this setup evolve tonight, and there's that elevated mix layer. That green line, that's the dew point curve. And that sharp caret oriented on the west-east, oriented on the x-axis, that's a big drop in dew point, a big dry slot coming in at the mid-levels of the atmosphere, steepening those lapse rates, and that's why we have that threat for very large, significant hail with this setup. And definitely stay tuned, everybody. I'll be broadcasting this live. I hope you guys enjoy my weather reports. I know you'd much rather have me out there in the field, but we're going to be breaking down this setup live through radar, watching the environments, breaking down the hodographs, seeing how the wind shear evolves available to these storms and how their storm mode and whether they're surface-based or elevated. Also, moving into the western gradient of that low-level jet later on this evening. So stay tuned. A lot of meteorology to be learned through this evening. And thank you for tuning in to my weather reports. And I hope you guys have a great rest of your Tuesday. Stay safe.